Hey guys, today's video I'm gonna talk like Charles from Charles in Charge. It's an old TV show. He's a New York guy. He's Charles in Charge. So the way I remember Charles Law is there used to be a TV show called Charles in Charge, and here you could see the Charles in Charge TV show. I loved this as a kid. So I know I'm just a little bit older than you guys, so this might not be something you know about, but what's key to remember is Charles in Charge was on TV, right? It's a TV show. And so Charles Law deals with the relationship between temperature and volume. And so Charles Law can be summarized or written mathematically as V1 over T1 equals V2 over T2. Let's take a look conceptually at how this Charles Law works. Heat a can, a compressed can of gas or something like that, because the gas will expand. The volume will be too great for the can and it could explode. So here's the most basic type of Charles Law problem, but it says what is the new volume? So we know what they're asking for. They're asking for V2 of a balloon that is heated to 600 degrees Kelvin if it initially holds 2 liters of gas at 300 Kelvin. And again, when we do temperatures with these gas laws, we cannot use Celsius. So I know V1 is 300 K. I know V1 is 2 liters. T1 is 300 K. V2 we don't know, and T2 is 600 K. So if we use Charles' Law, V1 over T1 equals V2, which is our X, over T2. And you can do this as a ratio. It's pretty easy to see, or we can just cross multiply 2 times 600 and then X times 300, and we end up with 1200. You should be able to do this in your head. You shouldn't need a calculator. 1200 liter Kelvin equals 300 Kelvin times X. 300 Kelvin we divide to the other side. The Kelvin units cancel and we get X is equal to 4 liters. Which we should be able to guess, right? If we're doubling the temperature, and initially it's at 300 Kelvin, and we double it to 600 Kelvin, then the volume should double as well. This is a direct relationship. This is not an inverse relationship, the relationship between volume and temperature.